As a recall, when we need to factor an expression where we have the form ax squared plus bx plus c and the value of a is 1, we need two numbers that add to the middle term and multiply to the constant or the final term. So they're going to add to the number that is in b and multiply to the number that is in c. So keeping that in mind, to bring it back from right before we left, we need two numbers that are going to multiply to 20 and add to 9. When we go through our multiplication, we see that that is positive 4 and positive 5. 4 times 5 is 20, 4 plus 5 is 9. So what we end up doing to factor, because the number in front of the x squared term is 1, that x squared breaks down to be an x in each bracket, and our magic numbers that we found go right in the brackets. So let's see. If we can't recognize right away, we set up our work. Two numbers that multiply to 6 and add to 7. Positive 1 and positive 6. Those numbers go right in the brackets. X plus 1, x plus 6. As you try the other two examples, eventually we have two numbers that multiply to negative 40. If they need to multiply to negative 40, the combinations are a positive number times a negative number or a negative number times a positive number. If they add to negative 3, then the negative number is going to be bigger. So when we start doing our multiplication tables, 1 times 40, 2 times 20, 3 times not a nice number, 4 times 10, 5 times 8. Ooh, 5 and 8 are 3 apart. So we have 5 and 8. To get to negative 3, the negative number needs to be bigger. So it's going to be negative 8 and positive 5. Those numbers go right into the brackets. X plus 5, x minus 8. Of course, if you can do this in your head, you go right to the answer. So in my head, I need two numbers that multiply to 36 and add to 20. 1 times 36, 2 times 18. Ooh, 2 and 18 add to 20. And those are simple trinomials. Again, simple meaning that the coefficient in front of the leading term is 1. If we now take what we know about common factoring and apply that to simple trinomials, everything stays the same. The first thing we want to do is we want to find a common factor. So I look and I say, ooh, the coefficient leading the first term is not 1. Can I factor it out? Is it a common factor for every single term? All of them are even, so I can pull out 2, or I can divide each term by 2. So now, because I've taken it out, I'm going to have 1, 2, 3 terms in brackets. 2x squared divided by 2 is x squared. 22x divided by 2 is 11x. And 56 divided by 2 is 28. Now I treat that trinomial as a simple trinomial, because now the coefficient, the leading coefficient, is 1. So again, I'm going to need two numbers that multiply to 28 and add to 11. As I go through combinations, I have positive 4 and positive 7. So that trinomial factors into x plus 4 and x plus 7. The common factor that I took out doesn't disappear. It remains there. It is still in front. When we apply this to quadratics, we'll notice that that is the a value in both standard form and factored form, and it is the same a value. It is still positive, telling us that the parabola opens up. So let's try this whole thing again. I'm looking for a common factor. All of these can be divided by 6. 6x squared divided by 6. 24x divided by 6. Negative 30 divided by 6. Now need two numbers that multiply to negative 5 and add to 4. To get to negative 5, I'm going to have 1 and 5. 1 times 5. Those are 4 apart. If I need to be positive, I need positive 5 and negative 1. The leading coefficient, or the leading factor, common factor of 6 remains. My trinomial factors down to x minus 1 and x plus 5. Let's try the next two. I look at what I can take out. 4. Leaves me x squared plus x minus 2. Two numbers that multiply to negative 2 and add to 1 are going to be 1 times 2. If I need it to be positive 2, it's going to be 2. Take away 1. Eventually, this is all the work that we are required to show. This is my load-bearing steps. If I need to show my magic numbers for my work, that's absolutely fine, but this is the minimum amount of steps to show my work. Same thing. 7. Instead of x, I have b. 28b divided by 7. 4. Negative 147 divided by 7. Negative 21. Look for my combinations. 3 times 7 is 21. 7 take away 3 is 4. And I have it fully factored. If I use that application-wise, I want to figure out dimensions that represent this rectangle. The entire area is x squared plus 5x plus 6. That doesn't mean length and width and 6 more. It means that that is the expression for the area. Now we're used to a rectangle seeing length times width. Area is length times width. Well, that's the same as like something in brackets times something in brackets. So is there any way that we can make this trinomial be something in brackets times something in brackets? All we're going to do is we're going to factor. We need two numbers that multiply to 6 and add to 5. Two times 3 is 6. 2 plus 3 is 5. So now we have a length and we have a width. In our mind, we are usually thinking that length is longer. So I might call that my length and that my width. But remember, it's just the orientation, whether it's a landscape or portrait. We might look at it that way. In our mind, we usually say that the length is the longer side. So can you recognize that x plus 3 is probably longer than x plus 2? Now, if I tell you that x is actually worth 1 meter, can we figure out the dimensions of this rectangular water garden? So for the width, once we know x is actually worth 1, the width is 3 meters. For the length, once we know that x is actually worth 1, the length is 4 meters. If we want to double check, we can check the area. Length times width, 3 times 4 is 12. We could always sub in x is worth 1 meter into our standard form or our expanded form for the area. 1 squared is 1. 5 times 1 is 5 plus 6. 1 plus 5 plus 6 is 12. So no matter which form, we still have an area of 12 meters squared. Common factoring. Always look for a common factor first. Pull it out. If there isn't one, is it a simple trinomial? Can we use our magic numbers to factor it to a binomial times a binomial?